Sharding. Hello guys, welcome back to my channel. Today we are going to talk about sharding. What is sharding? Sharding is a database partitioning technique used by blockchain companies with the purpose of sociability, enabling them to process more transactions per second. Sharding splits a blockchain company's entire network into smaller partitions known as shards. Each shard is comprised of its own data, making it distinctive and independent when compared to other shards. Sharding can help reduce the latency of slowness of a network since it splits a blockchain network into separate shards. However, there are some security concerns surrounding sharding in which shards can be attacked. Sharding is a database partitioning technique being considered by blockchain networks and being tested by Ethereum. The more users that blockchain network takes on, the slower the network becomes, leading to significant latency. Sharding can improve network latency for splitting a blockchain network into separate shards, each with its own data separate from other shards. Security concerns surrounding sharding, including a hack or shard takeover, where one shard attacks another, resulting in a loss of information. Understanding sharding. Blockchain networks are their respective cryptocurrencies are gaining in popularity due to the widespread application of the technology, which includes supply chain management and financial transactions. As the popularity of blockchain grows, so too does the workload and transactional volume that is handled by the network. If we think of a blockchain as a shared database, as more and more data is added, the network needs to find new, new ways to be able to process all of that data efficiently and quickly, which is where sharding can help. Distributed ledger of blockchain technology makes it attractive since it allows the transactions to be consequently shared across multiple sites and geographies. As transactions are recorded, copies are sent to the shared network within seconds, creating public witnesses. If one portion of the network falls victim to fraud or a malicious attack, the shared network's participants can identify what was changed by the fraudsters since they all maintain a copy of the ledger's transaction. As a result, blockchain technology and its distributed ledger system can help reduce fraud and limit the damage from cyber attacks such as a hack. Scalability. However, one of the major challenges with blockchain technology is that as additional computers are added to the network and more transactions are processed, the network can be bogged down, slowing the process called latency. Called latency. Latency is a hurdle to blockchain being adopted for widespread use, particularly when compared to the current electronic payment systems that work quickly and efficiently. In other words, scalability is a challenge for blockchain since the network may not be able to handle the increased amounts of data and transaction flow as more and more industries adopt the technology. One of the solutions being considered for creating latency free scalability is the process of sharding. Sharding is designed to spread out the workload of a network into portions, which may help reduce latency and allow more transactions to be processed by the blockchain. These traits that blockchain network seeks to employ are decentralization, scalability, and security. How sharding is accomplished. Before exploring how sharding is accomplished within a blockchain network, it's important to review how data is currently stored and processed. Blockchain nodes. Currently in blockchain, each node in a network must process or handle all of the transaction volumes within the network. Nodes in a blockchain are independent and are responsible for maintaining and storing all of the data within a decentralized network. In other words, each node must store critical information such as account balances and transaction history. Blockchain networks were established so that every node must process all of the operations data and transactions on the network. While it ensures a blockchain security by storing every transactions in all over the nodes, this model slows transactions processing considerably. Slow speeds for processing transactions do not bode well for a future in which blockchain becomes responsible for millions of transactions. Sharding can help since it partitions or spreads out the transactional workload from a blockchain network so that every node doesn't need to handle or process all the blockchain's workload. In a way, sharding compartmentalizes the workload into partitions or shards. Horizontal partitioning. Sharding can be accomplished through the horizontal partitioning of databases through division into rows. Shards, as the rows are called, conceptualized based on characteristics. For example, one shard might be responsible for storing the state and transaction history for a specific type of address. Also, it might be possible to divide shards based on the type of digital asset stored in them. Transactions involving that digital asset might be made possible through a combination of shards. As an example, consider a rental real estate transaction in which multiple shards are involved. These shards correspond to different entities involved in the transaction, from customer names to digital keys configured into a smart lock that is made available to the renter upon rent payment. So this is it for today, guys, for what is sharding. I will see you in the part 2 of this video. Thanks for watching.